Okay, this is a series of the first in a series of videos about geomapping. Here's an example of a quite old map. It includes a rich set of data, in this case the geological strata of England, Scotland and Wales. So it's quite an old map, probably done in the 19th century, and it was prepared effectively by hand, both in terms of collecting the data and drawing the map. A little bit later on we'll have a look at a modern geomap containing these data and think about how much easier it is to do these days, frankly. For now, let's think about how it would have been done by hand back in the day. It would have been a long walk while looking at the ground for the geologists. They would walk across the country collecting rocks and fossils, cross-referencing them to develop an understanding of how the geology was changing. So quite a tedious process. For a start, it would involve regularly surveying their location using the techniques of the day, which would have been quite time consuming apart from anything else. The first geological survey of the country was carried out by the blue-coated gentlemen of the Ordnance Topographic Survey, who travelled the country armed with theodolites and geological hammers, collecting information to fill in the basic Ordnance Survey maps. Their blue coats meant they were occasionally mistaken for the police of the day, which may not have made their jobs any easier. It was quite a lot to do. It was estimated at £1, that's per square mile, back in 1853. So the area of GB is about 94,000 square miles, or about 244,000 square kilometres. So it would have been quite costly. As we'll see in this series, the development of GPS and development of free tools such as ArcGIS and rich data sets being already available means the techniques used to require the resources of NASA or a large number of people can be done by individuals and small groups. If you're interested in the history of mapping in this country, the BGS webpage referenced there are some excellent resources. Its series of short YouTube videos are well and truly recommended. Most of us are familiar with GPS, which is useful for many other things than directing drivers over convenient cliffs. It's based on signals sent from a constellation of satellites orbiting the Earth. There can be problems if you have an unobstructed line of sight, which I'm going to give you an example of a little bit later on. But generally you can specify your location to at least within a few metres. These days GPS is built into smartphones and many digital cameras, providing us a very nice way of fixing the location of a place of interest. This allows us to collect data quickly and then we can import it into mapping programs. These are some of the maps from an exceptional final year project done by one of our students last year. It involved geotagging with photographs all 157 food outlets in Middlesbrough. That information was used to produce a detailed map of the food outlets in the town. Data on deprivation was obtained from the ONS and used with Philippa's information to throw a light on the important question of whether Middlesbrough has food deserts, food deserts. That is, areas in which healthy foods are hard to access due to either financial or physical barriers such as shop location and the expense of healthy foods. Now, just a few years ago, this type of project would have been impossible for an individual student, no matter how hardworking and talented. Developments in GPS and mapping and data collection and analysis have revolutionised what we can do to address these important questions. Okay, so a little bit of a nomenclature. One problem with geomapping is that it is a jargon-rich environment, and here's an example. Terminology does need to be defined accurately in academic writing, of course, hence the reference here, but sometimes, as I often say, a helicopter view definition can be a bit of a help. A shapefile is a data format invented by Esri, who developed ArcGIS. It can also be used with other GIS systems such as Google Earth. Click the link here if you want to know the details. Which you may certainly want to do if you're referencing. For most purposes, however, we just need to know what they contain and how to use them and how to make them. So shapefiles define the way points, lines and polygons are stored and displayed in maps and databases. So these could be footpaths or lakes or points, such as the location of Brian Clough's statue, and there he is. Let's consider Rotary Topping, the Eiger of Cleveland. It is of course a hill, and a very nice hill. is a satellite view of the North Riding National Monument, so we can see many features such as roads, villages, woodland and the hill itself. We've now switched to a topographical map. This is a detailed representation of the landscape including contours. Shapefiles define the way points, lines and polygons are stored and displayed, as I mentioned. There's also a concept of things such as waypoints. So for example, a waypoint here could be the summit of Rosebery Topping or the cafe in Newton under Rosebery. We can also specify the position of waypoints using coordinates such as latitude and longitude. And there were the latitude and longitude coordinates for Rosebery Topping. There is another coordinate system called northing and easting which is used. Much of the UK data uses this system, and the values need to be converted into latitude and longitude for use with ArcGIS, but we'll talk about that in a later video. Okay, in the meantime, here's a shapefile of the whole of the United Kingdom. We can add more detail, such as specifying the broad geographical regions of the country, or bringing in the counties, and we can drill down to further information as well. Here's a website we've all seen before in the Marmot Report video series and various lectures. That for the Office of National Statistics, specifically the neighbourhood statistics information. Here's the shapefiles for first for the local authority, and then one of the town's middle super output areas, and finally a lower super output areas. Again, I've discussed these previously, but I will revise these concepts a bit later on in the series as well. We can bring a little more jargon here. The underlying map of the town is an example of a base map. This is a map that underlies layers of information we can place on it. There's a number of base maps available in ArcGIS, and we'll start looking at them shortly. We can also have point information. Here's a base map using satellite imagery of the town centre, with point information for no very good reason showing the locations of public houses in the vicinity of the campus. Don't quite know why I chose that. Locations and areas can be tagged with additional information, such as this one for the Dickens information, which no one seems to want to recommend. We can also upload information, such as from data sets on public health and all maps, taking a more serious view of what we can do with this. Okay, enough of this preamble. Let's now have a look at where you can get the software from and the very basics of what you can do with it. Oops, no one does. Okay, the software. All the software we're using here is free. There are paid-for add-ons, and if you read a lot of the information that's available in using ArcGIS, for example, it will point to them. We won't be using them. We'll only be using software that is free. There are a number of alternative systems for geographic information, such as Google Earth, available. Many of the file systems are easily transferable between the programs. We're going to concentrate on ArcGIS, and you can download it for free from that link. Make sure you download ArcGIS Explorer Desktop, because that's the one that's free. This is an Android app and is available from the App Store. It's free. The QR code below will open the download page on your Android phone if you have one. I've tried a few GPS apps over the past few weeks, and this is probably the best one I've found so far, especially in terms of geotagging photos, a key requirement when we're collecting data. If you like shiny things, sorry there doesn't seem to be an iPhone version, but I'm sure you can find apps with similar functionality for Apple devices. The GPS Essentials app is packed with features, and we'll probably come back to it in a later video. But for now, we'll close the presentation and have a look at some of the basics of ArcGIS. Okay, this is ArcGIS Explorer loading. Sometimes I get a bit stuck here. If it does, after a couple of minutes, just restart it, it should be fine. That one's worked okay. You'll probably get a message saying the colour scheme's changed from Windows 7 or whatever you're using. Again, you don't need to worry about that. It will re-change to whatever it was before when you close the program. Okay, here's the ArcGIS Explorer desktop. There's a number of areas in this. Obviously there's a world map, which I'll have a look at in a minute. There's a menu bar here, and there's another menu bar tucked away. We're going to have a look at some aspects of this menu bar today, and the other things in later videos. There's a find region here, so if we click on there, we type in Middlesbrough. In this case it remembers what I'm looking for, because I've searched for it before. It comes up with a little bubble saying this is where Middlesbrough is. Now we can zoom in, or we can navigate using this particular control here, which is sort of okay. alternately you can just hold down the left mouse button and drag things around and use the mouse wheel to zoom in and out. Okay, so I'll zoom in and out so we get a reasonably sort of distant view of the region. Right, this is obviously a satellite map, and if you look down here we'll see it's got the base map, Bing Maps Aerial. This is one of a number of satellite maps are available. There are other maps available. If you go to base map and you click on, for example, Bing Maps Road, that'll try to do itself, and it brings up the sort of thing you'd see in a road atlas. So there's quite a few of these, so I'll have a little play with them. Okay, for now I'm just going to zoom out quite a long way. We're also going to get rid of the Middlesbrough thing by clicking on that. Because what I want to do is load up a shapefile, or a KML file as they're called. The file extension is KML, which stands for Keyhole Markup Language. It's the file format for Google Earth basically. So what I'm going to do is use the Add Content button to go to KML Files. Now I know this one's on my desktop, so I'll go to Desktop. And it's this one, which is a file of the geology of the United Kingdom basically. So it'll open up. It'll take a little while to do because this is quite a big map, and that is a problem with a lot of these KML files. They can rapidly become very large, so you need to be a little bit careful about that. Okay, when you try to move this around you'll find it's a lot slower if you download this particular map. Okay, so I'm sort of struggling a bit here to zoom in, but it is slowly zooming in. Okay, so we'll zoom into somewhere on the coast and we'll have a look at the sort of information that exists in these layers. Now if you remember, the underlying map is a base map showing roads, and you can just see it poking through the layer which we've just placed on top. So this is an example of a layer, in this case a layer for geology. Alright, we'll continue to scroll in. So this is very slow because there's a lot of information in this map. Okay, we'll let it settle down a bit. Now if we click on there, it will in a moment bring us up a little bit of information, which tells us that this is a sandstone laid down in the middle Jurassic, which we would expect. This whole region here was under a shallow sea in the Jurassic. So that's the sort of information we can have. You can also have things like photographs, and we can see here a link to a website. So lots of information you can tag points and areas with. Okay, so I'm going to close that up. I'm going to go over here and get rid of the geology one, because it's quite a big one. So I've hidden this. Right, so what we're going to do now is bring up another KML file of public houses in Middlesbrough. So go to Add Content again, go to KML Files, it's on my desktop again, and it's Borough Pubs. Now we'll notice straight away it's zoomed into sort of like the extent of the data, which is quite useful. If you collect data in an area, when you upload it to ArcGIS, it'll zoom in to just show you that area. So alright, we'll have a little zoom into the town, where all the pubs are of course, and where the university is coincidentally. Right, so we zoomed in right there, and we found Salford Road, and Dickens Inn appears to have moved next to the star. Now this is the problem with data. It's often incorrect. For example, if you get data for postcodes for the location of a shop, perhaps a food shop from our perspective, you may find if it's on Linthorpe Road, for example, the postcode will give you a location which is the geographical centre of Linthorpe Road, which may be like a mile away from where the actual shop is. I'm going to change the base map here. I'm going to change it to which I'm going to change it to. I'm going to change it to imagery. That's the first one I want to change it to. It'll try to do itself again. It takes a while for this to open up, but there we go. Right, so let's just orient ourselves a bit. It's a nice map this, because you can clearly see the Middlesbrough Tower, there's Salford Road, and there, as we say, is the Dickens and the Star next to each other. Obviously the Dickens is over here, many of us will know that. Let's have a little wander around. Okay, so there's a library. I'm going to get rid of the pubs for now, because we've made that point. Okay, there's the library, and what do we have looking behind it? We don't have the Olympia building, we don't have the all-weather playing field, and we don't have the Centuria South building. Some of these maps are quite out of date, so if we go from where I'm in a minute, it's Bing Maps Imagery to Bing Maps Aerial again. changes, and we'll notice now, oh look, there's the Olympia, the playing field, and the Centuria South building with its strange enigmatic innards. So you've got to be a bit careful about some of these maps. You may find that your geographically tagged photo is accurate, but it is the building you've tagged isn't on the map. So be a little bit careful with that. Right, okay, I'm now going to add some photographs. I'm going to go to add to content again and go to add geotagged photographs. Okay, here's a little library of photographs, and I've got a couple here which I've taken of King Edward Square. The first one is taken from my office, so I'll upload that one, and it's sort of located it there. We'll come back and have a look at what it looks like in a second, and add the other photograph, which is taken from King Edward Square, basically. Right, so now we notice straight away they're not next door to each other. There's the university here. We've sort of identified the university. There's King Edward Square, and there's a picture which appears to be in the right place, and the picture over here, we'll find it again, which is very much not in the right place. It's somewhere near Newport Road. Well, let's have a look at the picture. That's quite a nice one, I think. So it's looking out of my office window down King Edward Square. Now the problem with this, of course, is it's looking out the office window, so it's only seeing a part of the sky, the satellite phone, the GPS detector on the phone, that is. If you can't get a sort of 360 view of the sky, your position may be somewhat off. In this case, it's off by quite a long way. On the other hand, if you look at this one, we'll just open it up. Perhaps not as nice an image, but there's a turning circle and there's King Edward Square. And if we zoom in a little bit to wherever we were, I've lost it. There we are there. This is basically exactly where I took it from. Okay, so I got my phone out, set the camera up in the software, not the main camera that comes with the phone, the camera that comes with the software I recommended earlier, and took the photograph. That allowed plenty of time for the satellites to be detected by the phone, and we got a good location. So there we are. I think that's all I want to say at the minute. Thanks for listening.